Hi everybody. Today's topic is going to be on probability and statistics. And this is a topic that is not covered in your text. So there are several handouts available in your assignment sheet. And this video will hopefully help you understand a little bit about the basics of probability and statistics. A lot of the probability issues I believe are going to be pretty intuitive to you. They're going to make sense. They're going to include ideas that you've already thought about. It'll include questions and ideas about flipping a coin, or rolling a six-sided die, or picking a card from a deck of 52 cards, and talking about the probabilities included there. So let's just look at a couple of questions that will make perfectly good sense to you, and I think the answers will make sense also. So let's suppose we're going to roll a six-sided die, and we want to say what's the probability that you get a 5. So that is written like this: the probability of a 5. There's 6 possibilities, and only one of them gives us what we want. So that's the probability of getting a 5. How about the probability of getting an even number? Well, an even number is a 2 or a 4 or a 6, so there's 3 ways that can happen out of a total of 6. So the probability of rolling an even number is 3/6 or a half. I'm sure that these questions are perfectly reasonable to you. So here's a more interesting question. Let's suppose you have a drawer and there are 3 pairs of socks in the drawer. 1 pair is red, 1 pair is white, and 1 pair is blue. So let's suppose what you're going to do now is pick 2 socks at random. And what we're asking for is, what's the probability that you get a matching pair? So the way to think about that is, you pick 1 sock out, and it's either going to be a red one, or a white one, or a blue one. Whatever that is, there's 5 socks remaining, and only one of them is going to be the one that's going to match. So the probability of getting a matching pair is going to be 1/5. And finally, let's look at the case where you pick a card from a deck of 52 cards. The probability that you get an ace. Well, there's 52 cards that you can pick, and out of those 52 cards, there are 4 aces. Probability that you get a spade. Well, same thing. There's 52 cards that you can pick, and exactly 13 of them are spades. So that's basic, simple probability cases. So let's talk about independent events. Let's see if I can underline that. Independent events. That's when the occurrence of one of these events is unaffected by the occurrence of the other. An example might be you flip a coin once and then you flip a coin again. What happened on the second flip is independent or unaffected by what happened on the first coin flip. You pull out 2 socks. You pick out, well, let's go back to that previous example where you have 3 pairs of socks. Suppose you pick a sock out and you look at the color and then you put it back. And then you pick another sock. Whatever you got on whatever color the second sock was doesn't depend upon the first sock. People have 2 children. Whatever the gender is of the second child is independent of the gender of the first child. So those are examples of independent events. And let's look at some specific examples and talk about how we compute the probabilities. So let's suppose that you just take a coin and you flip it 5 times. Each time you flip it, the result is independent of what's happened before. So the probability of getting 5 heads is simply going to be a half times a half times a half 5 times. And it's going to be simply 1/2 to the 5th. So here's a more interesting case. Let's suppose that a family has 3 children that are born. And we're asking, what's the probability that these 3 children include 2 boys and a girl? Now, what you have to understand is that there's different ways that those children could be born. You could have a boy, and then a boy, and then a girl. Or you could have a boy, and then a girl, and then a boy. Or you could have a girl, and then 2 boys. In each case, because these events are independent, this probability is going to be 1/8, this probability is going to be 1/8, and this probability is going to be 1/8. And so the probability that we have just 2 boys and a girl is going to be 3/8. We simply add those up. So hopefully what you see is that when you have successive independent events, like flipping a coin or having children, what you do to get the probability of the entire event is you multiply the probabilities of each little event. So suppose an experiment consists of rolling a 6-sided die and then picking a card. And what we're asking for is the probability that we get a 2 on the die and a heart. So these are independent events, and so the probability is simply going to be the probability of the 2 times the probability of a heart. And that is the probability of 2 independent events. We multiply the probabilities. So we also want to make sure we understand and define what we mean by mutually exclusive events. And these are events which have no outcomes in common. Here are a couple of examples. So here are 2 examples of mutually exclusive events. First one, you pick a card, and you're asking what's the probability that you're going to get a 7 or a king. Well, it's either a 7 or a king. They don't have anything in common. There are 4 ways to get a 7, and there are 4 ways to get a king. Whoop, let's get that right. And so the probability that you get either a 7 or a king is 8 out of 52. We add them together. Rolling a die, you can get a 1 or a 5, and so the probability is 2 out of 6. So that sort of suggests the rule. Let's see if I have some room to write it. And so you see the rule here is that if we're going to compute the probability of mutually exclusive events, we simply add the 2 probabilities together. All right, so those are the 2 big rules. Let's look at an example or 2 for this. So what we're going to do here is flip a coin 4 times, and we want the probability of getting exactly 2 heads. This is a lot like the problem with the 3 children and getting 2 boys, because there are a lot of ways that we can get exactly 2 heads. Let's see if we can write them all out. We can get a head, and then a tail, and then a tail. Or we can get a head, and then a tail, and then a tail, and then a head. Or we can get a head, and then a tail, and then a head, and then a tail. Or we can get a tail, and then a head, and then a head, and then a tail, or a tail, and a head, and a tail, and a head, or a tail, and a tail, and a head, and a head. I think that's all the ways that you can get exactly 2 heads. Now, each of these 6 occurrences are independent events. The probability of any one of these events, anyone, anywhere, is a half. And so each of these then has a probability of 1/2 to the 4th, or 1/16. So the probability that this happens is a 16th, the probability that this happens is a 16th, probability that this happens is a 16th, and so on. And since there are 6 of these possibilities, the probability of getting exactly 2 heads is going to be 6 out of 16. So here's an example where each of these 6 events are mutually exclusive. Each event consists of 4 independent events, and so to get the probability of the 4 independent events, we multiply a half times a half times a half times a half. To get the probability of the entire thing happening, which is 2 heads, each of these is mutually exclusive, and so we add up the probabilities. 1/16, 1/16, 1/16, 1/16, 1/16, 1/16, and we get 6/16. All right? So those are the basics of probability. Probably enough you need to know to answer the questions and to perform well on the SAT. Now we'll look at some questions from statistics. So statistics is all about the analysis of data. And you've seen statistics, you've used some statistics, at least you've talked about the average of numbers, which in statistics is referred to as the mean. And what we'll do is we'll simply define and give you examples of how to understand some of the other terms, what they mean, and look at an example or two. And one of the things to be very aware of is that in this work, we're going to make big use of the Inspire. And ideally, you've been using the Inspire throughout all of your work so far. But this is one case in which you are basically unable to answer some of the questions unless you have your Inspire. And let me just remind you that the link for the Inspire manual is on your assignment sheet. So let's look at this very simple set of data, and we'll use this to analyze or help us understand what some of these terms are. So I'm not going to spend the time in the video showing you how to use your Inspire. You can use the manual, or your teacher can help you, or a friend can help you. But all of this information can be gleaned very quickly from using your Inspire. First thing that we get is that the mean of this set of data, the average, turns out to be 10. And you should be checking this with your Inspire just to make sure that you're getting it correctly. The median is the middle piece of data. If you have an odd number of pieces of data, then it's simply the very middle. If you have an even number of sets of data, like we do here with 14, then you take the two middle ones and you find the average. And in this case, the median is going to be 8. And why is it 8? Because it's the average of the two middle ones, 7 and 9. The range is going to simply be the difference between the maximum and the minimum. In this case, it's 25 minus 1, or 24. The standard deviation is the one that you really need your calculator to compute. And this is a number that gives you some idea of how spread out the data is. Now, when we use our Inspire on this set of data, the standard deviation comes out to be somewhere around 7.77. And it measures the spread of the data. So just visually, suppose we have data that looks like this, as opposed to data that looks like this. This will be a small value for the standard deviation, and this will be a larger value for the standard deviation. So that's just a visual way of seeing when the data, in this case, isn't very spread out from the mean. The standard deviation is small. When there's a lot of data that spreads out from the mean, the standard deviation will be larger. The median divides your data in half. Quartiles divide the data into fourths. And so the first quartile is going to be 4. The second quartile is simply the median, which is 8. And the third quartile is 17. In other words, 1/4 of the data is above 17. 3/4 of the data is below 17. And finally, the 5-number summary includes the minimum value, the first quartile, the median, which is really the second quartile, the third quartile, and the max. So for this example, here's what we'd have. So the minimum value is 1, the first quartile 4, the median is 8, the third quartile 7, and the maximum value is 25. Pretty simple. And I just want to emphasize that all of this stuff is delivered very, very quickly by your calculator. So this is a result of creating a histogram using my Inspire. And it simply shows you the spread of the data. And so if you look at this, each of these little digits is a 2. So this is telling you there's no data between 12 and 14. There's no data between 22 and 24. There's a lot of data between 4 and 6. And pretty much the rest of the data is kind of spread out evenly. And so you'll learn how to draw those histograms using your Inspire. And again, one more time, I'll remind you to go to your manual, which you can find online, and that will lead you through the steps to create a histogram. And finally, the last visual representation we have of data is using a box plot. And this really is a way to visualize the 5 pieces of information. So right here at the left is the minimum value, which is 1. At the right is the maximum value, which is 25. Remember that? Right here in the middle line, is the median, which is 8. Here's our first quartile, looks like 4. And here's our third quartile, which is 17. And so, again, you'll learn how to use these either in class or by reading the manual. And so that takes care of the statistics portion of this lecture.